Hello guys, welcome to Verilog Programming with Xilinx Vivar Design Suite. We are from Digitronics Nepal. So let's go to our today's section. Actually, we are in section 2, which is simulating Verilog code with Testbench. So in this section, we are going to have idea about basic concept of simulation and Testbench. Sometimes Testbench for our simulation module for Verilog is also called as test fixture. However, we mostly term it Testbench. And we will have 3 lecture sessions. First is basic concept of simulation testbench. In section 2 or lecture 2 we have device under test, that is DUT, and lecture 3 we have instantiate stimulus. These 3 sections will introduce in this section 2. So I'm talking about simulation. Actually, simulation is the process of creating a virtual environment and testing any functionality in virtual environment. So if we want to test our design on hardware, that consumes more time, resources, and even money. So what we can do is we can simulate the design, can simulate that functionality in computer-aided tools or SDL compilers or SDL simulators like is Vivado simulator, iSim simulator, quarter simulator, model sim simulator, etc. There are lots of third-party simulator and major vendor simulator, and we can test our design on that simulator so we can understand the result, understand the accuracy of our result. So finally only in the final scenario only we can implement our design on hardware. So we need to have hardware in every time. So here we can see basic concept of Testbench. Actually, we will have top layer of module including functionality, and inside of that module we will have instance top, and inside of that we will have DUT. So that DUT is utilized for creating Testbench, which includes instantiation of stimulus. So after completing this lecture, you will be able to know about simulation, creating Testbench, and different functional modules of simulation. So as we have talked, simulation is utilized mostly for design verification. So this simulation process actually assure the quality, the functionality, the operation of any modules. So before any project ship to market, we need to verify the design. So that verification process is done by simulation tools. So most of the design time, 60 to 70% of design time is invested or utilized for simulation. So that is done for verification of any design. So we need to have assurance of the accuracy, performance, and operation functionality of the module, which can be obtained from simulators. So the simulation source is called as Testbench, and sometimes the Verilog simulation source is also called as test fixture. So the test fixture inside consists of device under test, that is actually module definition, and after that device under test we will have instantiation of stimulus. That stimulus actually the steps for different test case scenario. So we will have instantiate, or we will have initialize some values for different input ports in that instantiate stimulus. So here is the basic example of Testbench for clock generator. Actually this clock generator consists of some definition of module, counter Testbench, and there are some registers and wires. Actually register is utilized for some clock signal reset and enable, and wire is utilized for final result. So we can see counter u0. Actually this segment is also called as device under test. This is the main module of counter or component of counter. This counter is simulated by this test bench. After this counter ends, so this clock is mapped with clock, reset of counter is mapped with this reset, enable is mapped with this enable, count is mapped with this wire count, and finally counter DUT has been closed here. So we have initial and we have begin, so as well as we have end. So in between that we have defined some, where we have initialized some values for that inputs. So that is input are clock, reset and enable. So these are the inputs which have been initialized by 0 value, and we have always and #5. Actually #5 is delay 5 nanosecond. So we have clock equals not clock, so clock is inverted, clock is toggle. So when clock is high, next step clock is low, and another step clock is high. So finally we have in module. So this is the very basic example of clock generator. And as we talk, hash and number initialized for delay. So we have used 5 nanosecond of delay, and we can have semicolon after the single line of delay, so we can utilize that line and we can use our statement in that line too. So we need to have separate delay line. So this is the definition of delay. And initial block is actually the block which actually have definition of instant stimulus. That stimulus actually defines the input or initialize the values for input ports. So here is initial block, which can be seen here, initial begin, and the values are initialized this condition, first condition, and in second condition the value is initialized for different condition, different scenario. So this initial block also consists of initialization of some values to the port, delay, some display elements. Sometimes we might have to have display, so we can use display keyword, display function for display any result. And another is display element. So display statement has been here, so we can see this dollar display actually represents the display of any line. So that will display this line. Actually this line consists of some values of x, decimal, binary, other values. So here we have very basic sample test bench. Actually we are going to utilize this test bench for simulating AND gate. Actually we also have designed AND gate in previous lab, that is lab 1, and in this lab 2.1, actually this lab upcoming lab is 2.1. so in lab 2.1 we are going to initially design that AND gate again, and we are going to create a simulation test bench ourselves by utilizing this source, and we are going to generate the waveform for that AND gate. So let's see the sample test bench for AND gate. So here is module AND gate TB. This is actually MPT module. Test bench consists of MPT module, so there is no any port declaration inside of that test bench module. And we have some wire and register. Actually register is used for inputs and wire is used for output here. And another is AND gate, my AND gate. So my gate. So this is the another AND gate design example. While we have designed AND gate in our design, so this must be module my gate. Actually here are some mistakes here. So this consists of this port has been mapped with this defined port. So A has been mapped with TA, B has been mapped with TB, Y of AND gate has been mapped with TY, and we have initial and we have begin, and we have this monitor line. Actually this monitor line monitors the states, and after then we have initialization of values. Actually TA has been initialized with 1-B0, that is 1 bit binary value has been 0. So 1 bit binary 0 value, 1 bit binary 1 value. So 1 bit binary only consists of 1 or 0. So we don't need to have 1-B in this scenario, but this is the standard procedure for defining or initializing any variable value or any value to the variables. So we can see sample test bench consists of 1-p0, which is actually 1-bit binary initialized by 0 value. We can get this type of waveform from that type of simulation test bench we are going to utilize in upcoming lab session. So we have one quiz section. Actually DUT is also introduced in this another lecture. Actually DUT is the block which is represented from the main module. So our main module is AND gate, so that AND gate is represented in DUT in this segment. And we also have some example here which we are going to talk on later session, and we also have quiz here, and this is the end of this section. So guys, thanks for watching this section second, which is simulating Verilog module with test bench or test fixture, and we'll have lab session in another video session of Vivado. So guys, meet you in another lab session.